Example 24. A rectangular canal is to discharge 1.86 cubic meters per second per meter width of channel with a minimum energy content. Compute the following: the minimum energy content, the critical depth, the velocity of flow. So we are given the idea that the flow will have minimum energy content, so therefore it occurs at the critical depth. The canal is rectangular, therefore the minimum energy content is 3/2 of the critical depth, and the critical depth is cube root of small q square, quantity small q square over g. So substitute E minimum equals 3/2 of cube root of 1.86 square over 9.81. So the minimum energy content is 1.06 meters. The critical depth can be computed from cube root of q square over g, or critical depth is 2/3 of A minimum, 2/3 of 1.06. So I'll just use this formula here. Cube root of 1.86 square over 9.81. The answer is the same if you multiply 1.06 by 2/3 from this formula here. So critical depth for rectangular channel is 2/3 of E minimum. So 0.7065 meters. Then the velocity of flow. The velocity of flow is critical velocity because the depth is critical. So the critical velocity is Q, 1.86 divided by critical depth. Or you may use the direct formula, square root of G d sub z. So I'll use this first. So 1.86 over 0.7065, critical velocity, or the velocity of flow, is 2.633 meters per second. The direct formula for rectangular section, the critical velocity is square root of g critical depth. So if you use that formula, square root of 9.81 times 0.7065, the answer would be the same. So that's it.